I am Sidra Tirunum, holding ID number 215956160. With a group of 5 members in regard with our assessment 1 in module Advanced Software Engineering, here we choose a domain named IoT and we have selected a subtopic called fog computing. Combiningly, it is the Internet of Things in fog computing. To our very interesting topic. So first of all, I would like to introduce what actually IoT means. IoT is a collection of network of connected devices that facilitates communication between devices and cloud as well as between the devices themselves. The IoT refers to interconnection of everyday devices, objects, and appliances through the internet. So this is basically allows us for increased automation, efficiency, and insight in various areas such as smart homes, healthcare, transportation, and industrial applications. Further, moving to our main concept, that is fog computing. What actually fog computing means? Fog computing is a virtual computing model, that connects cloud servers and IoT devices by distributed network, storage, and computational services. It actually focuses on assisting applications and demands, which performs only low latency services from end devices. Now let's discuss
About research and challenges and issue, protocol and network security, identify management, privacy, trust and governance, fault tolerance, access control, creating knowledge and big data. I will focus on three major issues. Protocol and network security. A protocol primarily referred to as an access method use a standard to define a SIM for exchanging data over a various computer networks such as a local area network or LAN, internet, etc. In addition, in privacy, aid in maintaining anatomy and individuality of user or things privacy in a IoT of utmost concern as it is necessary to protect the information of individual things or person from disclosure to the IoT environment. Other point is creating knowledge in big data can be expressed as a two side of some coin. Let's discuss about when computing, latency reduction, improve response time, reduce cost bandwidth, increase the security, greater data privacy, enhance service for remote location. I will explain some of this improved response time with a reduction in network latency. Real-time application will benefit from improved response time and a greater overall use experience. And other reduced cost of bandwidth. A certain data can be processed locally without being sent to cloud. Less network bandwidth will require. Will the ever increasing number of IoT devices all generating live data, this bandwidth saving could be considered. We will moving forward to critical analysis and discussion. The paper provides a comprehensive review of the literature on the fog computing and the Internet of Things, which suggests that the author have conducted a systematic and rigorous search for the relevant studies. However, the paper does not report on the specific method used for the literature review, which may affect the repeatability and transparency of the study. Additionally, the paper does not provide empirical evidence or case studies to support the claims and recommendations made, which may limit the generalizability and the applicability of the findings. To improve the research validity and integrity of the study, the author could have conducted a systematic literature review using well-established protocols, such as the pre-referred reporting item for systematic reviews and meta-analysis guidelines. The author could have also included case studies or empirical data to support their claims and recommendations, which would increase the reliability and validity of the study. The paper detailed analysis of the fog computing is a state-of-art technologies, networking protocols, programming frameworks, layer architecture of fog computing, various deployment models, and fundamental concepts. And one of them is a layer architecture of fog computing. Is the first one is physical and virtualization layer. It they perform the primary task of capturing data and are located at various locations, usually involve sensing technology to capture their surrounding. It can be a part of a standalone or a large devices. Second one is a monitoring layer, is that monitor time, work, temperature, and other physical properties, and to maximize the battery life of the devices. The pre-processing layer, Data is cleaned and checked for any unwanted data present. Data impurity is removed and only useful data is collected. Is a temporary storage is associated with non-permanent distribution and reapplication of data. Storage visualization like VSAN is used in this layer. In security layer is involved with the privacy of data, the integrity of data, encryption, and the description of the data. The next one is the transparent layer is to upload the partially processed and the fine-grained secure data to the cloud layer for permanent storage. For efficiency purpose, the portion of data is collected and uploaded. Turning our attention now to
Next generation Internet of Things application in fog networks, intelligent transportation systems, smart healthcare, smart agriculture, smart homes, smart grid, augmented reality. Smart home. As an explained, imagine a smart home that use IoT devices such as thermostat, cameras, and door locks. Traditionally, these devices would send their data to a centralized cloud server for processing and storage. However, with the implementation of fog computing, the device data can be processed and stored at the network edge closer to the devices. For example, the data generated by the cameras can be processed locally to detect and identify or suspicious activities, and thermostat can analyze the temperature data locally to optimize energy consumption, and the door locks can use facial recognition to get access to authorized person. By using fog computing, the smart home can be more efficient, reliable, and secure as the data is processed and stored locally, reducing latency and ensuring data privacy. Let's move on to the methodology. The authors use a qualitative analysis approach to synthesize an existing knowledge on fog computing and identify the key concepts and challenges. The authors rely on a variety of data resources, including academic papers, books, reports, and online resources. The authors use a thematic analysis approach to identify a categories the key concept and challenges of the fog computing. Let's discussion about.
Future research direction. In this data, security, privacy, dynamic and agile pricing model, heterogeneity, distributed deep learning, energy efficient data offloading, dynamic QoS requirement, reliability, network communication, workload prediction, and runtime estimation. There are some key points I will be discussing. First is heterogeneity. Heterogeneity is one of the most significant issue for fog networks, as data generated from different devices have different structures, format, and characteristics. Current research focus on VM allocation, container deployment, and integration of new hardware such as CPU, GPU, and FPGA in heterogeneous environment without proper standardization. Next is workload prediction and runtime estimation. Most existing scheduling algorithms deliver IoT application to compare devices like fog nodes, containers, or VM instance on compatible cloud servers in a surveillance environment. Let's see energy efficient data offloading. The incorporation of advanced communication technologies such as beyond 5G or 6G also optimize delay and network configuration while transferring data, eventually reducing the energy. Conclusion. Let me sum up my main points. The article provides a comprehensive overview of fog computing and its potential application in the Internet of Things. While there are still challenges to be addressed, fog computing represents a promising approach for improving the efficiency and effectiveness of IoT systems. Further research and evaluation are needed to determine the empirical evidence and applicability of the findings. Improving the research design, data collection, and reporting of result would enhance the research validity and the integrity of the study. These are all the reference from where we research our data.
Thank you for listening us.